Question 1. In light of recent developments, a homeowner named Istazanaka requested radon mitigation in his recently renovated single-family home. The basement has a finished floor with new vinyl tile over concrete, and the HVAC system uses a high-efficiency furnace with sealed combustion. During diagnostic testing, the contractor notes elevated radon levels despite the home's mechanical system operating correctly. What should the mitigation specialist prioritize when developing the mitigation plan? A. Increase general ventilation using an HRV system integrated with the HVAC supply duct. B. Seal all visible cracks in the vinyl tile to reduce radon entry points. C. Install an active subslab depressurization system with proper pressure field extension. D. Install passive stack system with an exhaust vent above the roof line. Answer. Correct answer. C. Explanation. Active subslab depressurization, as is the EPA's preferred method for mitigating radon in homes with concrete slabs. EPA Radon Mitigation Standards, Section 3.1. Sealing the vinyl tile alone is insufficient because radon can still permeate through concrete. HRV systems may supplement mitigation but are not primary solutions unless used in specific cases. Astomy. Passive systems are generally less effective in existing homes unless paired with fan assistance. Pressure field extension ensures radon gases are drawn toward the suction point effectively. Question 2. The traditional approach to managing crawlspace radon entry often includes depressurization. In a situation where a home has an unvented crawlspace with a plastic vapor barrier installed, which of the following is the most appropriate mitigation method? A. Install a HRV system directly in the crawlspace. B. Apply negative pressure beneath the vapor barrier using a dedicated fan and sealed seams. C. Increase natural ventilation openings to the outside. D. Remove the vapor barrier and seal the crawlspace with concrete. Answer. Correct answer. B. Explanation. According to EPA standards, EPA 400-2R93078, crawlspace depressurization beneath a sealed vapor barrier is the most effective and preferred method. This approach controls radon migration while maintaining energy efficiency. Increasing natural ventilation may not reliably reduce radon and can increase energy costs. HVACs in crawlspaces aren't effective unless paired with HVACR solutions. Concrete sealing is not cost-effective or practical in retrofit applications. Question 3. From the perspective of accurate diagnostics, why is it essential to perform a pressure field extension test before finalizing the location of suction points for an SSD system? A. To ensure fan noise is minimized throughout the house. B. To confirm radon is completely removed before installation. C. To verify that suction influences radon entry points across the entire subslab. D. To allow the installer to test alternative measurement devices. Answer. Correct answer. C. Explanation. The FEE test helps determine whether suction from a proposed suction point can adequately influence radon gas migration beneath the slab. Atomy Section 7.5 that ensures coverage of the slab area without needing multiple fans. Fan noise A is important but unrelated to E. The system doesn't remove radon prior to installation. B. Testing devices. D is unrelated to the function of a FEE test. Question 4. Throughout the course of radon mitigation projects, technicians may observe varied results even with identical mitigation systems. What factor primarily contributes to the variability in system performance between different buildings? A. Ceiling height differences in the basement. B. Soil permeability and composition beneath the structure. C. Type of HVAC system installed. D. Age of the building's roof construction. Answer. Correct answer. B. Explanation. Soil type is one of the most critical determinants of radon system effectiveness. EPA 400-2R93078, Section 2. Permeable soils like gravel allow better subslab airflow, increasing system efficiency. Tight clay soils resist pressure field extension. Ceiling height and roof construction have negligible impact. HVAC type can influence air pressure slightly but is secondary to soil conditions. Question 5. Given the circumstances, Is Delgado's home has elevated radon levels, but it's located in an area with frequent power outages. She is concerned that an active system may not function consistently. Which of the following approaches should the mitigation specialist recommend? A. Suggest passive system only as it requires no electricity. B. Install an active SSD system with battery backup or alarm system. C. Recommend only sealing foundation cracks. D. Delay installation until the electrical utility becomes more reliable. Answer. Correct answer. B. Explanation. Active SSD systems are more effective than passive ones, even with occasional power outages. Radon mitigation standards. When power reliability is a concern, installing alarms and battery backups ensures homeowners are alerted to system failure per RPP guidance. Sealing alone is not a mitigation solution. Delaying installation risks continued exposure to elevated radon. Question 6. When analyzing radon mitigation fan installation, what is the primary safety concern related to placing the fan in a basement or living area? A. Reduced radon reduction efficiency. B. Excessive noise from fan operation. C. Potential for radon-rich air leakage into living spaces. D. Higher installation cost. Answer. Correct answer. C. Explanation. EPA Guidance EPA 400 2R93078 Section 233 and ATOMI prohibit locate in radon fans in conditioned or occupied spaces. If the fan housing fails, it could leak radon-laden air into the living area, increasing exposure risk. Efficiency A is secondary to safety. Noise B and cost D are minor concerns compared to potential health hazards. Question 7. Demonstrated by diagnostic testing, a radon mitigation system installed in Ista Choi's home shows persistently high post-mitigation radon levels. The fan is operational and all visible seals are intact. Which of the following should be the next best course of action? A. Retest in 6 months to account for seasonal variations. B. Add additional suction points and conduct. A new feed test. C. Replace the fan with a more powerful model without testing. D. Suggest moving the discharge pipe higher above the roof line. Answer. Correct answer. B. Explanation. If the initial SSD system is underperforming despite functioning equipment, it likely means insufficient pressure field extension. EPA and ATOM standards recommend reassessing slab coverage by adding suction points. ASTME Section 7.5. Retesting without changes is ineffective. Upgrading the fan without diagnostic evidence may not resolve sub-slab limitations. Exhaust height rarely impacts overall radon mitigation. Question 8. With the advent of new building codes requiring sealed sump pits, what consideration must a radon mitigation specialist make when integrating the pit into an SSD system? A. Sumps should never be part of a radon system due to water vapor. B. The pit must be vented independently of the SSD system. C. The pit can serve as a suction point if properly sealed and covered. D. The cover must be permanently glued shut to prevent air leakage. Answer. Correct answer. C. Explanation. Sealed sump pits can serve as effective suction points in SSD systems when appropriately sealed and airtight. EPA 400 2R93078 properly integrated. They reduce the need for extra coring and improve sub-slab communication. Independent venting. B is not typically necessary. Gluing the cover. D can prevent maintenance access, violating serviceability principles. Question 9. To illustrate this point, when installing a radon mitigation system in a split-level home with multiple foundation levels, what is the best strategy to ensure effective sub-slab depressurization? A. Install a suction point only in the lowest slab area. B. Create inter-slab connections and test pressure field extension across all slab areas. C. Place suction points based on slab size regardless of elevation. D. Use passive ventilation and fan delay timers. Answer. Correct answer. B. Explanation. In homes with multiple slabs, inter-slab connections are vital to achieving uniform depressurization. ASTME Section 753. Without them, radon from isolated areas may escape mitigation. Elevation alone doesn't determine effectiveness. Passive methods are insufficient for complex foundations. Fan timers are irrelevant to radon mitigation efficacy. Question 10. The prevailing attitude toward radon in commercial buildings is that mitigation should follow residential guidelines. Which of the following is not a correct assumption regarding this approach? A. All areas with human occupancy should be tested and mitigated if needed. B. Commercial buildings require less mitigation because of higher ventilation rates. C. Commercial radon mitigation may require customized systems due to complex HVAC integration. D. Continuous monitoring is often more applicable in commercial settings. Answer. Correct answer. B. Explanation. While ventilation in commercial buildings may be higher, assuming that mitigation isn't needed is incorrect and can endanger occupants. Epitechnical Guidance 402K93008. Radon can still accumulate in low ventilation zones. Commercial systems often require complex integration with HVAC, customized diagnostics, and continuous monitoring due to changing occupancy system operation. Question 11. In a modern context of radon mitigation, this is green has a home with an exposed basement wall partially embedded into a hillside. The radon levels are high and airflow seems to vary seasonally. The mitigation specialist installs an active SSD system, but radon levels remain above upper limits in winter. What is the most probable explanation? A. The seasonal stack effect is overwhelming the SSD system's capacity. B. The exposed wall is acting as an intake for outdoor radon sources. C. The fan is installed improperly on the discharge line. D. The HVAC system is producing excess supply air. Answer. Correct answer. A. Explanation. Stack effect is more pronounced in winter due to greater temperature differences, drawing more radon from soil into the structure. EPA 402R93078. Even functioning SSD systems may struggle if pressure field extension is inadequate. Outdoor radon is typically negligible. Improper fan installation can impact efficiency, but wouldn't show seasonal variation alone. HVAC supply issues wouldn't elevate winter radon levels unless depressurization were extreme. Question 12. While examining a radon mitigation system in a multifamily building, the technician notes that the exhaust stack terminates just 1 foot above a window on the upper floor. Which of the following best explains why this setup is non-compliant? A. The discharge must terminate a minimum of 6 feet above the slab level. B. The discharge pipe must not terminate within 10 feet of any opening into the building. C. Discharge piping should be concealed for aesthetic purposes. D. The discharge should always point downward to avoid rain entry. Answer. Correct answer. B. Explanation. According to ANSI RMLB 2018 and EPA mitigation guidelines, the exhaust point must be at least 10 feet from windows, doors, or other openings to prevent radon re-entry. This protects upper floor occupants and ensures radon doesn't re-enter the structure. Aesthetic concealment is not code issue. Downward-facing discharge is incorrect and can allow re-entrainment or water accumulation. Question 13. The evolution of radon testing has seen a shift toward continuous radon monitor or RMS. What is a primary advantage of RMS over charcoal canisters and pre- and post-mitigation diagnostics? A. CRMS are less sensitive to humidity changes. B. ERMS require no calibration or maintenance. C. ERMS provide time-integrated and hourly data for better interpretation. ERMS are cheaper and easier to dispose of. Answer. Correct answer. C. Explanation RMS offer the advantage of hour-by-hour data logging, which helps identify diurnal or HVAC-related patterns in radon levels, making them superior for diagnostic UNPPK plan. They are more expensive, require calibration, and are not disposable. Charcoal canisters provide only average radon levels over time with no temporal resolution. Question 14. As a result of repeated radon system fan failures in Mr. Patel's home, the specialist is called to investigate. The home has high humidity levels and is located in coastal region. Which of the following design improvements is most appropriate? A. Install condensate drain loop in the vertical discharge pipe. B. Replace the fan with smaller model to reduce motor stress. C. Move the fan to the basement to protect it from weather. D. Install lateral discharge vent through the side wall. Answer. Correct answer. A. Explanation. High humidity can lead to condensation buildup in vertical discharge piping. This condensation can drain back into the fan, causing electrical failure. A condensate bypass loop or drain line prevents water from entering the fan. EPA 400 2R93078. Smaller fans won't resolve condensation problems. Indoor fans are prohibited by EPA guidelines. Lateral discharge can lead to radon re-entrainment and is non-compliant. Question 15. From a practical standpoint, a mitigation contractor installs an SSD system in a home with an interior drain tile loop. However, the radon levels remain elevated post-mitigation. What is the most likely explanation? A. The drain tile system is improperly connected and leaking air. B. The suction point was placed too far from the electrical panel. C. The HVAC blower is too strong and counteracts the suction. D. The fan is oversized, reducing pressure field control. Answer. Correct answer. A. Explanation. When interior drain tile is present, it can be used as a high-efficiency suction network only if sealed properly. If it leaks air or isn't continuous, pressure distribution suffers. EPA 400 2R93078. Fan size and HVAC airflows can affect performance, but air leakage is the most common issue with integrated tile loops. Electrical panel location is irrelevant. Question 16. Contrary to popular belief, sealing alone is not sufficient to mitigate radon levels. What is the main reason sealing is not considered a standalone mitigation strategy? A. Sealing increases indoor humidity. B. Sealants often release VOCs. C. Radon can still infiltrate through unobservable openings and pores. D. Sealing raises negative pressure in the building. Answer. Correct answer. C. Explanation. The EPA and asked to emphasize that sealing is a supplemental measure. It helps improve system efficiency but cannot block all radon entry points, especially through concrete micropores and inaccessible joints. Astomy, VOC emissions and humidity are concerns but not reasons sealing fails as the standalone method. Negative pressure is caused by building design, not sealing. Question 17. The foundation of system diagnostics includes performing pressure field extension tests. Which method is most accurate for determining the effectiveness of a pressure field in a radon system? A. Smoke pencil testing across multiple floor levels. B. Manometer pressure readings at the fan inlet. C. Micromanometer readings at multiple subslab test holes. D. Visual inspection of airflow from exhaust. Answer. Correct answer. C. Explanation. Micromanometer testing at various subslab locations provides quantitative verification that pressure under the slab is consistently negative, which is essential for determining if radon gas will be redirected. Astomy Section 7. Smoke pencils and visual methods are subjective and unreliable. Fan manometers only measure system operation, not slab effectiveness. Question 18. When faced with a high-rise commercial building with mechanical ventilation and central HVAC, the building manager is hesitant to allow an SSD system. What mitigation approach is often suitable in these cases? A. HRV systems at each occupied floor. B. Pressurize the building with make-up air and seal the basement. C. Lower thermostat set points during the day. D. Install a passive roof stack with internal ducting. Answer. Correct answer. B. Explanation. In commercial settings, building pressurization using outdoor make-up air can prevent radon from entering, especially when SSD systems are impractical due to slab design or tenant access. EPA Technical Guidance 400 2K93008 HRVS may help, but are usually insufficient alone. Thermostat changes do not address radon. Passive stacks are ineffective in large structures. Question 19. Examining the consequences of improper discharge location, a mitigation contractor places the radon exhaust pipe under the eave near the attic vent. Why is this? A safety concern. A. It may cause freezing in the attic. B. The discharge could be pulled back into the building through the vent. C. It obstructs rooftop access for maintenance. D. The discharge may corrode the vent grill. Answer. Correct answer. B. Explanation. EPA and ANSI guidelines RMLB 2018 prohibit placing discharge points near air intakes or attic vents due to re-entrainment of radon into the living space. This defeats the purpose of the mitigation system and can lead to health hazards. Freezing, corrosion, and obstruction may occur, but are not the primary concern. Question 20. To better understand radon mitigation safety, which of the following best represents a necessary electrical safety measure when wiring? A radon fan. A fan must be wired directly to HVAC power to ensure simultaneous operation. B. Fan wiring should include a disconnect switch located within line of sight. C. Fan must use extension cords in temporary installations. D. Wiring can only be done after final radon test results. Answer. Correct answer. B. Explanation. According to NEC National Electrical Code and EPA radon mitigation standards, a disconnect switch must be installed within sight of the radon fan for servicing and emergency shutoff. Wiring to HVAC power can cause improper cycling. Extension cords are never permitted for permanent installations. Wiring should be done before final testing to allow system operation. Question 21. Among the various components of an active radon mitigation system, Mr. Reynolds notices his newly installed system isn't showing pressure differential on the YouTube manometer. The fan is running and the system has the suction point on a basement slab. Which of the following is the most likely cause? A. The suction point is located too close to a foundation wall. B. There is a break or disconnection in the exhaust piping. C. The fan is incorrectly wired and running in reverse. D. There is insufficient sealing around sump lids. Answer. Correct answer. B. Explanation. A lack of pressure differential in a YouTube manometer despite a running fan typically indicates an air leak or pipe disconnection that prevents negative pressure from developing. EPA 402R93078, Section 343. While improper sealing or poor suction point placement can reduce effectiveness, they don't eliminate pressure differential entirely. Fans cannot run in reverse due to design. Question 22. In response to a weak mitigation challenge is Baker is working on a home with a monolithic slab foundation and very low clearance for coring. Which technique would provide the most appropriate radon mitigation solution? A. Install passive ventilation along the perimeter. B. Use a perimeter drain loop as a suction path. C. Apply crawl space depressurization techniques. D. Drill into wall floor joints to access the subslab zone. Answer. Correct answer. D. Explanation. In monolithic slab homes, subslab access can be difficult. EPA guidance allows coring near wall floor joints to access gravel or soil zones below for suction point creation atomy. Passive ventilation is not effective. Perimeter drains and crawl space methods aren't applicable here unless those features exist, which they typically don't in monolithic slabs. Question 23. By comparing two identical SSD installations, one in humid climate and one in dry climate, why might the humid climate system require more frequent maintenance? A. Radon levels are higher in humid environments. B. Condensate buildup can cause fan or piping failure. C. Soil porosity increases in humid regions. D. Humidity interferes with manometer accuracy. Answer. Correct answer. B. Explanation. High humidity can cause condensation inside radon exhaust piping, especially in vertical risers. If not drained properly, this moisture can backflow into the fan, leading to electrical failure or reduced suction. EPA 402R93078. Radon is not directly related to humidity. Soil porosity isn't governed by climate alone. Manometers may fog, but they remain accurate. Question 24. With respect to system efficiency, what is the most critical reason for using a pressure field extension fee test during or after the installation of a subslab depressurization system? A. Ensures the fan meets electrical code efficiency requirements. B. It confirms that subslab negative pressure extends across all radon entry zones. C. It determines the necessity of additional ventilation. D. It helps identify radon entry from water sources. Answer. Correct answer. B. Explanation. The purpose of a fee test is to verify that the suction created by the fan extends beneath all necessary portions of the slab, ensuring radon entry points are covered. Atomy Section 7.5. Electrical efficiency is unrelated. Ventilation and waterborne radon require separate diagnostics. Without fee confirmation, some areas may remain untreated. Question 25. Focusing specifically on Mr. Ammon's recently retrofitted home, the mitigation technician notices sump pit that is unsealed and located close to the suction point. Radon readings post-installation are still above 4.0 psil. What should be the technician's next step? A. Seal the sump pit at site and retest the system. B. Install a HRV system to increase general air exchange. C. Increase the fan size and power rating. D. Add another suction point near the pit. Answer. Correct answer. A. Explanation. Unsealed sump pits can act as major radon entry points. EPA guidance 402R93078 mandates that sumps used in mitigation systems must be sealed airtight, especially when located near suction point. HVACR may be helpful but not first-line corrections. Adding suction points may be unnecessary if the issue is a leak. Fan upgrades are ineffective without addressing the air leak. Question 26. Taking into account the complexity of crawl space mitigation, why is it important that the plastic vapor barrier used in crawl space depressurization be fully sealed at seams and edges? A. To reduce noise transmission from the fan. B. To prevent soil gases from bypassing the depressurization system. C. To comply with waterproofing codes. D. To reduce backdraft from combustion appliances. Answer. Correct answer. B. Explanation. The purpose of the vapor barrier is to isolate the soil from the indoor air and create a sealed zone for effective suction. If it's not sealed, radon can bypass the system entirely. EPA 400 2K93008. Noise, waterproofing, and backdrafting are secondary concerns. Sealing ensures that negative pressure is applied across the soil surface beneath the barrier. Question 27. Through the lens of liability and best practice, which of the following should be included in the documentation left with the homeowner after mitigation system installation? A. Fan serial number, system schematic, and post-mitigation test results. B. Owner's phone number and utility provider's contact. C. Daily worker logs and equipment service reports. D. Insurance certificates for all subcontractors. Answer. Correct answer. A. Explanation. Per ANSI RMS standards, mitigation professionals must leave documentation with system description, fan make middle serial, contact info, radon test results, and maintenance guidance. Utility data or service logs are not required. Insurance certificates are administrative and unrelated to client education. This ensures homeowner transparency and future servicing readiness. Question 20. The core principles of HVAC system interaction dictate that radon mitigation should avoid creating building depressurization. Which system design feature is most effective in avoiding depressurization-related backdrafting of combustion appliances? A. Installing passive make-up air vents in furnace closets. B. Sealing foundation wall penetrations. C. Installing powered make-up air supply with pressure control. D. Using flexible ducting to reduce airflow resistance. Answer. Correct answer. C. Explanation. Backdrafting occurs when indoor air pressure becomes too negative, pulling combustion gases into the living space. Powered make-up air systems with pressure controls ensure balanced air pressure and prevent this hazard. EPA 400 2R93078. Passive vents are inconsistent. Wall sealing prevents radon ingress but doesn't manage HVAC-induced pressure imbalances. Question 29. Looking at the data on high radon readings in newer energy-efficient homes, which of the following best explains this phenomenon? A. They use building materials with higher radon emissions. B. They often lack crawl spaces or basements. C. They are more airtight, reducing natural dilution of indoor air. D. Their HVAC systems use low MERV-rated filters. Answer. Correct answer. C. Explanation. Modern energy-efficient homes are built tightly to reduce energy loss, which limits natural ventilation, allowing radon to accumulate. EPA Indoor Environments Division. While building materials contribute small amounts of radon, the main factor is reduced air exchange. Filter ratings have no significant impact. Crawl spaces vary by region but aren't causative. Question 30. To determine whether a system's fan has failed, homeowner reports the YouTube manometer shows equal height columns. The fan sounds normal. What should the specialist do first? A. Recommend immediate replacement of the fan motor. B. Verify electrical supply and current draw on the fan. C. Remove the fan and inspect impeller rotation. D. Check for duct blockage or disconnected piping. Answer. Correct answer. D. Explanation. Equal heights in a U-tube manometer indicate no pressure differential, possibly due to disconnected or blocked piping even if the fan is running. EPA guidelines emphasize checking for visible damage or disconnected pipes before replacing components. Electrical diagnostics and motor inspections are secondary. The fan may still run but not function effectively.